All right, so I'm gonna repeat this because that was not recorded properly. So we put the difference data of L1 and L2 in, we put the difference between time 1 and time 2 in L1, and we have to decide whether we need this difference to be greater than 0, less than 0, or different from 0. Well, what he says the question here, do patients show a significant increase? So we want, just from time 1 to time 2 to increase. So that means the numbers in time 2, he want them to be larger than time 1. And this is how I pose this always. So I come up with a number for time 1, let's say 7. And since he's asking for an increase, I'll make it a 9 for time 2. And 7 minus 9, guys, is negative. So we need to select mu of d to be less than 0 here. To find the test statistic, we've already done that. So I put the data in L1 and then I went to stat tests, t-test. I selected mu0 is always testing against 0. My list is in L1 and we need less than here. Negative 2.349. P-value, I think you were observing the p-value, is 0.015. Oh, 490. And what's alpha here? He didn't give us alpha here. So I'm gonna use 5% here. So it is less than 5, so you reject HO. Oh, alpha, yeah, it is 5%, sorry, it's right here. So there is sufficient evidence or enough evidence show significant increase in mean. Here's another one. The pass completion percentage of 10 college football quarters for their freshman and sophomore seasons are shown in the table. At alpha equal 10%, is there enough evidence to support the claim that the pass completion percentage have changed? Okay, guys, same thing. You have to do a subtract. This one minus that one. And then put it in L1 and run the test. But let's decide, just on the null. So what's the claim? The pass rate have changed right here. Can you guys tell me from those 6, which one is going to be your null and alternative hypothesis? That should be easy. Change means it could be greater, increase or decrease, either one. So it not one specifically. What would be the null and the alternative hypothesis? Is it A, B, C, D, E, or F? Any ideas? A change, guys, is different from 0. So we'll be here, right here, not equal to 0. That's what a change is. So let me pause the recording for a second and let's put the data. So again, we put the differences in L2 and we run the t-test against 0. Just gonna do it one more time, guys, because it is important. You will have one question from this section for sure. L2 and, oops, why it keeps doing this? Okay. Different from, that's the alternative, and then calculate. Okay, he says, what is D bar? D bar means the sample mean of the differences, which is X bar in our case, negative 1.58. S, which is the standard deviation of the difference, 3.702, 3 decimal places. Now the test statistic, guys, is negative 1.34350. Oh, 2 decimal places, so 3.5. P-value, let me bring it back. It's 0.21. How many decimal places? 3.210. Okay, and let's see now. Oh, let's see part E. I didn't see this in there. Okay, so we don't fail to reject the null hypothesis. The results of using the p-value are always the same as using the critical value approach. I'll make sure this will not show. So fail to reject the null hypothesis. There is not enough evidence to what? Change. Change means the claim is in HA, so there is not enough evidence to support the claim that the completion rate have changed. Here you go, guys. Okay. Now the last one part of section chapter 8 is 8.4. It's a two proportion Z test here. In a study of binge drinking, the percent who said that they have engaged in unplanned activities because of drinking alcohol was 24%. In 1993, N was 155. And 29% in 2005, N is 492. Is this change statistically significant? At the 0.05 significance level, complete parts A to C. Okay, so specify the hypothesis, choose the correct answer below. 1993 is a P1 and 2005 is P2. Change, he's asking about the change, guys, if there is a change. So he didn't say greater or less. So you know H1, HO, it's gonna be P1 equals P2 and P1 not equal to P2. Find the test statistic and the p-value, make a decision using a significance level of 0.05. So let me bring my calculator and see how we're gonna use this test. It's a last test in chapter 8, two proportion Z test, enter. And please pay attention to how we're gonna use this test here. Okay, X1. He didn't give me X1, but he gave me a percentage in population 1, but he gave me N to be 155. As I told you guys, if he gives you the percentage, I gave you the hint here. X1 is P1 times N1 and X2 is P2 times N2. So in order to find X1, you take the 0.24 and multiply by the sample size, which is 155. But it is a decimal, guys. You cannot have a decimal in there. So I'm going to put, the 155 and then go back and make this 37, round it to the nearest whole number. Because that's the supposed number of successes. It can't be a decimal. Let's go to X2. It is 29% of 492. So 0.29 times 492. And then put 492. And since I got a decimal, guys, I'll go back and fix this one. Make it 143. And P1 is different from P2. Calculate. And we're all set here. So Z is negative 1.26. P-value is 0.208. How many decimals? Nearest hundredth. So 2 decimal places. 0.21. We fail to reject the null hypothesis. We don't have sufficient evidence to reject the null hypothesis. We are unable to show that there is a difference in the proportion because we fail to reject the null hypothesis. All right. Last one, using proportion from chapter 8. Use the figure to the right, which shows the percentage of adults from several countries who favor building new nuclear power plants in their country. The survey included random samples of 1,017 adults from country A, 1,058 adults from country B, 1,119 adults from country C, and 1,030 adults from country D. We might not need to use all of those, just probably one country or two, comparing two countries. At alpha equals 6%, can you reject the claim that the proportion of adults in country A who favor building new nuclear power plants in their country is the same as the proportion of adults in country B? So A and B, we want to check if they are equal. Okay, what's the claim? Proportion of adults in country A who favor building new nuclear power plants in their country is the same as the proportion. That's the claim. Okay, can a student tell me which one is the correct null and alternative? That should be easy, guys. Is it A, B, C, D, E, or F?
E.
Yep, I agree. And let's take you to the calculator and do this. Two proportion Z test. All right. Okay, we need country A and country B. He didn't give me X1, guys, but he gave me country A to be 48%. So look what you do. You take the 48% and multiply by the total from country A. And how much was country A? He says 1,017. Sometimes he'll give you the X values, other times he doesn't. So enter. You see, it's a decimal, so I have to make it a whole number, 1,017. Now let's go to country B. Country B, as you can see where the mouse is moving, 49%, guys. You don't just put 49% here, you put 49% times the total from country B, which is 1,058. And that's 1,058. But don't run the test. It will not run because you have decimals in X1 and X2. So just go back, 488, round it, and round this to 518. And you should be able to do it now. Not equal to. Okay. So Z is negative 0.44. And p-value is 0.6565. How many decimals he wants? 3. So 657. So we got negative 0.44. And p-value, guys, is 0.657. You fail to reject HO definitely because the p-value is bigger. Okay. And can we reject the claim that they are the same? No, we fail to reject the claim. No. And that should conclude this. Okay. For the remaining parts, let me just stop here. And for the remaining parts, guys, I'm going to do a video for 14, 15, 16, 17, 18, and make it available to you because the time is not going to permit that we get them done. But by the time I enter the data into the calculator, the time will have expired by